ICSE batch, no?
Yes.
Can you keep it here? Attendance? Zero here. Strength is less, bro. How
Sir,
many?
exam.
Whose exam?
School.
At school or at UP? Also. So how many children are not here today?
5.
5, 6 are less today.
5.
They were there in the maths lecture or no?
No.
Okay. Where did we stop in the last class? Okay. So, did we do energy conversion? Huh? Conversion.
No, sir, we did the types of energy.
completed the forms of kinetic.
Let me open the textbook.
Sir, we did types of energy.
Types of energy. Okay.
Hydrogen.
So there are so many different types of energy, right? So, did we discuss this diagram? Conversion of energy. Did we do that?
No, sir.
Okay. So, forms of kinetic energy, right? Rotational, translational, vibrational.
Yes.
We finished that topic. Okay. So we'll be starting with convert. Okay. So then potential and kinetic energy difference, you can do it yourself, right? We've already discussed that. So conversion of potential energy into kinetic energy. The conversion of potential energy into kinetic energy. So as you know, potential energy is stored energy, right? Due to change of configuration of a body or due to its position, right? So if we take an example of a compressed spring, right? Let us say you have a relaxed spring which is like this, right? So this is a relaxed spring. Relaxed spring. So when it is compressed, let us say with the help of a finger, right? So when you compress it, you will feel some force in your finger. So you have changed the configuration of the spring. So what kind of energy it will gain? Because from here to here, suppose it traveled x, whatever force was applied by the finger in this direction, so Fx was the work done when compressing it. So whenever you work on the body, what do? That work is stored as its potential energy. Correct? So now the spring has potential energy, which is equal to Fx. Right? Or if you say this is H, then it will be Fh. And when you remove this force, when you remove this finger, then what will happen? So to see the effect of it, let us say we are keeping some bone. Okay? So what will happen when you remove the finger? It will be thrown up. It will try to regain its equilibrium state or natural state, right? So this, whatever this energy was, okay, it will now show up as kinetic energy of the ball. Got it? What will happen when you remove this finger? You will see that spring will attain the natural state and the ball will get a jerk. So it will fly. So since the ball is in motion, it will have some kinetic energy. Right? So from where it got its kinetic energy? From the potential energy of the spring. So when the spring is released, when the compressed spring is released, the stored potential energy in the spring is converted into the kinetic energy of the ball. Suffocation in the room or what? Feeling some kind of smell. Yeah. So you understood. When the compressed spring is released, the stored potential energy in the spring is converted into the kinetic energy of the ball. I'll just keep it open for a minute. I can feel some order. Are you feeling that? Some order. Shift a little. I need some space to keep on that side. So like that, there could be many examples of conversion of potential energy into kinetic energy. This is the first example. Any other example? Yeah. Mike? No? Bow and arrow, yes. So there is a bow and arrow example. I have already given it.
Yes.
Oh, yes, okay. So bow and arrow example, right? Anything else? Wound spring, right? So this is like compressed or uncompressed spring. Wound spring is like we have in a toy. So when you do you get toys these days like that? Do you have still? Okay. Or in a wristwatch, old mechanical wristwatch. Now we have all digital watches. But in old wristwatch, you have to wind it once in 24 hours. Have you seen that? Anybody using such wristwatch anymore? So you can visit some museum or see some video on YouTube. So wound spring is like there is right. So let us say it is tied over here. It is tied over here, and there is some lever connected over here. So when it is rotated, So it will just become something like this. Okay, it will get concentrated in a very small, it's wound, right? So then what will happen? Once this force is released, right, it will on its own go on unwinding. And if it is connected to the tires of the toy, so once you have tightened it, now it will start unrolling, so then it will start moving. So your car will begin to move. Have you seen that? So when you push it back and then release, the car runs ahead. Have you seen that? Those toy cars? So what is there in the toy car? So when you pull it backwards, these springs get wound. Okay, then it will start unwinding. Okay? Are you able to visualize? You are looking at some discomfort. Have you played that car? I mean, use that toy when you they bring it backwards. So this spring, which is attached to the tires of the car, it will get wound like छोटा हो जाएगा. बाद में क्या होगा? वो spring will start getting unwound, and because of that, there will be rotational motion developed in the tire, and it will suddenly go ahead. Once it is fully unwound, car will stop. The toy car. Okay. So what is happening here? So when you wind the spring, it will have potential energy. So when it is released, it will show up as kinetic energy of the toy.
So the car.
Yes. Good. So today you understood how it is working. So it is not working with the battery. It is like when you worked on it, your work got stored as potential energy of the spring. And now when you release it, the spring is working to take the car ahead. Okay? So no energy got created anywhere. Everybody worked, spent energy, and that sort of has different. Right? So what else? Freely falling stone, right? Freely falling stone from a height. So the stone is at this height. Right? So it is made to fall. It will have MGH. Right? That is the potential energy at the height. Okay? But when it falls, what is the height at the ground? 0. But now it will hit the ground with maximum speed. So then it has kinetic energy when it hits the ground. The entire potential energy is converted into its kinetic energy. Okay? So these are the potential energy to kinetic energy conversion we have seen. Right? In 4 cases. Go ahead, I'm not drawing the diagram again. You already have it. So any questions here? So I will ask question. Which type of potential energy has got converted here in all these examples? How many types of potential energies are there? Gravitational and elastic. Not elastic. In case 1, elastic. Case 2, right? Elastic. Bow and arrow is also elastic. Potential energy to kinetic. What about this? Elastic. So 3 examples are of elastic potential energy to kinetic. Right? Here also it is elastic to. So this is what you have to understand, right? Elastic to elastic potential energy to kinetic. What about the last case?
Gravitation.
Gravitation, right? So you're saying both there. So here, what is the conversion? Gravitational potential energy to kinetic. Okay. So these are the conversion which is taking place. Okay. 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 So these are concepts. Okay, so I'll be discussing. If you have any question, please ask. Can I erase it? Don't get confused by Fx. F generally is mg. Okay. So whatever force you have applied, right? So that force would be equal to the weight of the ball or something like that. Okay. Anything. Okay. Now next is only plain discussion, right? So we have seen here that potential energy is changing into kinetic energy. Now we will see how different forms of energy are changing from one to other, right? So everybody has textbook. So just let us discuss all the cases. So first one is, right now we are getting familiar with the, in article 2.14, we are going to what are the different forms of energy, right? So what are the different forms of energy? First is solar energy. So what is solar energy? Energy coming to us from sun. But can we use solar energy as it is, right? No, because it is in very diffuse state, so we can't use it productively directly. So to use energy, we have made certain devices, right? So to harness or trap solar energy, we use solar panel. If you want to heat water, for example, right? We use solar panel. So any surface which is like painted black, it absorbs a lot of heat from sun. And then any substance which we keep in contact with that will get heated, right? So like that. So solar panel helps us heat the water, for example. Then we have solar furnace. Furnace is very large heater. Okay. So in solar furnace, what we can do, we can have a like concave mirror, right? So whenever the sunlight comes, so it will be parallel line, and therefore it will get focused at some point. So wherever so we are using a big diameter, the big aperture concave mirror, so we can focus it somewhere. So all the sunlight is getting focused in a very small area, because what is the nature of image formed? In case of a parallel lines, so when the parallel lines are received by mirror, it will focus at a point. सब focus पे आ जाता है ना? So imagine what will be the intensity of light, very high in a small point. So anything you keep there will get heated very fast. So you can cook food or heat water, convert that into steam. That steam you can use to rotate a armature coil in the generator, and therefore electricity can also be produced. Okay, so there are many applications. So that's basically solar furnace. Then you have solar cells. These days everywhere we are seeing solar cells. What do they do? Convert solar energy into electrical energy directly, right? So here in the second example, in solar furnace first we heat and then convert to electrical energy. right? But in case of solar cell, directly sunlight is converted into electrical energy. So don't worry about it. It's a very long list of energy, but primarily these are 7 only. So 7 में से ही थोड़ा change किया हुआ. Then in my previous lecture, like what is solar, okay, will appear into light also. Then you have geothermal, right? So that is like variant of nuclear energy. Okay, so we'll discuss on that. So the second energy is heat energy. How do you get heat?
The energy released on board.
When you burn any substance, then heat is produced. So burning is a
Chemical.
chemical reaction. So every substance which produces a lot of heat after burning, here heat energy is received through chemical energy. Okay, right? So right now we are not saying which type of energy is converted. Right now we are just becoming familiar how we obtain heat energy by burning certain things. So what can we burn? Coal, oil, wood, gas, right? So this is what it is. So using heat energy we can do a lot of work. Why do we need energy? First of all, why do we need energy to do work? Right? Because energy is capacity to do work. So there are various sources of energy. Right? So we know right now the natural sources are getting exhausted very fast, which are the conventional sources of energy, like the coal reserves, the fossil fuels. They are like depleting very fast. Next 60, 70 years we'll be done with that. But as humans to survive, we have so much of energy needs. Electricity to chahiye. Can we imagine life today without electricity? No. So thankfully, we can produce electricity in various ways. Not just fossil fuels by burning them, but various ways. Okay. Light energy. So as long as sun is there, light energy will be there. What after sun sets? We convert electrical into light energy. Okay, na? So we need device. So to convert one energy to other energy, we need device. Okay. So here, what is light energy? It's a form of energy in presence of which other objects are seen. Right? That's how we define light. It lets us see things around. Again, chemical or fuel energy. So in heat energy, we said burning, right? So objects which are burned, okay, they have stored chemical energy, right? So energy possessed by fossil fuels such as coal, etc. So that's what I said. They are interrelated, lot of them, right? Okay. What about hydro energy?
Which energy produced by fast moving water.
Yes. So water, like a moving water has a lot of energy, right? So have you had a chance to bath under a tube well in village? No. Then how will you experience? Have you been under a waterfall? Right? So when the water hits your head, you feel like somebody is really hitting. So that kind of thing. So you would be advised not to be under a very high rise waterfall, right? Then it's crushed. Okay? So it's like that. So hydro energy, like moving water, has a lot of energy. That's why in flood cars are floating, right? Electrical energy. So what is electrical energy?
Energy possessed by moving electrons.
No, energy between electrically charged bodies. So when you have two bodies which are having opposite electrical charges, right? It will then make the electron to move. If any electron falls in between any two oppositely charged bodies, then the electron will run. Okay, so that appears as current, right? You understand? So what is electrical energy? It exists between
Two charges.
oppositely charged bodies. Okay? And how do you create oppositely charged bodies? One method is by running. Other method is like batteries. So in which you have electrolyte and then through chemical reaction, both terminals or both electrodes of the battery acquire different charges. One has positive, the other has negative. So the moment you have two oppositely charged body, you have electrical energy, right? Understood? So there are various ways in which we can create charge bodies. Then you have nuclear energy. What is nuclear energy?
It is the energy released due to nuclear fusion.
So what is fusion and fusion? So let me explain that. So see, what is nuclear energy? Okay. So there are two types, fission and fusion. Right? So in fission, one big nuclei is broken into two small nuclei. So one big nucleus, so let us say its mass was capital M, and then you have two nucleuses whose masses were M1 and M2. Right? So M is greater than M1 plus M2. The final nuclei masses is actually less than the parent nucleus. Okay? So therefore, there is a mass difference. What is delta M? It is M minus M1 plus M2. So Einstein actually gave a relation. He said every mass has an energy. What was Einstein's relation? E is equal to mc square, so mc square. So m is delta m, or E is equal to delta m c square. So the difference in the mass of the nucleus appears as energy. So whenever the new set of nuclei are formed, they are lighter than the parent nucleus. Okay, so that reduced mass has got converted into energy. Right? How that energy appears? That energy appears, so whenever you break a nuclei, it will produce a lot of heat. This heat is this energy, delta mc². Got it? Are you with me? So fission is when you break the bigger nuclei into two smaller nuclei, like uranium is broken into beryllium and krypton, right? Like that. So in higher classes, you will learn about nuclear reaction. In fusion, what is done is two small nuclei are fused to make one big nuclei. Okay? So in this case, we have M1, M2, and now you are getting a bigger nucleus. But the mass of the bigger nucleus is less than sum of masses of parent nucleus. So every time the final nucleus has less mass than parent nucleus, right? So again the mass difference appears as energy, right? So in this case, mass of M1 plus M2 now is greater than mass of the final nucleus. Okay. So therefore, delta M in this case is equal to M1 plus M2 minus M. So the energy is E is equal to delta M C square. What is C? What is C? Speed of light. Okay, so how much energy are we carrying? Mass multiplied by C square. It will be a big number. That many joules of energy each one of us are carrying, right? Okay. Any question? What is nuclear energy? So nuclear energy is created. So these are two nuclear reactions. These are not chemical reactions. These are just like chemical reactions. You must be familiar with. You have nuclear reactions also. The difference between chemical and nuclear reaction is the involvement of the scale of energies. Like in chemical reaction, energy produced is of the order of electron volts. But in nuclear reaction, the energy produced is million electron volts. Million times more energy is produced in a nuclear reaction. Got it? So we will achieve energy security if our country is flooded with nuclear power plants. But the problem is we don't have nuclear fuel, right? So we have to import the nuclear fuel from other countries like Australia, etc. Right? What is the nuclear fuel we use? Uranium. In India, we don't have much uranium, right? We have a lot of thorium though. So we are researching on how to make nuclear reactor which uses thorium as the raw material. Okay? Then we'll have energy security someday. Next is geothermal energy. Now, it's deep inside Earth. Some nuclear reactions are taking place. And as I explained, in every nuclear reaction, a lot of energy is produced. So deep inside Earth, right, when the nuclear reactions are taking place, it heats the surrounding area. And there are water tables. So when that water, groundwater, comes in touch with the heat produced due to nuclear reaction inside Earth, right? So that water gets converted into steam. So sometimes it explodes and comes out where you have hot water springs, okay? It's because of that. And sometimes the steam is very deep inside, so companies drill holes and then install pipes. So that steam comes out. That steam comes out with a very large force. That force is guided on to rotate the turbine of the generator. And then electricity can be produced. Okay? So that is geothermal energy. Right? So in India, we don't have much locations, but abroad, there are many countries who do have locations where there is a possibility to harness geothermal energy. Okay? So we don't have that. Understood? So energy released in nuclear disintegration in the interior of Earth gets stored deep inside the Earth and is called geothermal energy. Right? Okay. Then what is wind energy?
It is energy processed by in the air.
So just like water, a strong stream of wind also has energy. So how do we harness that? So we used to have windmills. So those winds will move the blades of the windmill. And then we will have some gear system using which the windmill is converted into, wind energy is converted into rotational or mechanical energy. That can be used to grind food grains, to make wheat flour, right? Wheat ko grind karke what to make? Wheat flour. So in old times we used to do that when we did not have this mechanical diesel-based engines. So wind power was exploited. These days we are exploiting wind power, wind energy to make electricity. So have you seen on the roads the windmills? No? Have you traveled to Gujarat or Shirdi by any chance? So you see big fans, like those are windmills, right? But they are producing electricity. Each blade is like almost 60 to 100 meter, just one blade. Like this is how much? This is less than a meter. So 100 blades like this. You can imagine what would be the diameter of. Okay. So understood wind energy? Then we have sound energy. So how do we get sound energy? Yeah. Right? Anything which is vibrating will produce sound. Plug the string of the guitar, right? How are we producing sound? What is vibrating in us?
In iron box.
Voice box.
Voice box. I mean, can you show me the box? It's vocal cords. The thing is vocal cord. I don't know. I've never heard voice box. Do we call it voice box? Vocal cords, yes, I have heard. And to vocal cords. So it is like vibrating, right? But its vibration could be different than the string vibration, which is more obvious, right? So it has a very complicated dynamics, right? Okay. So sound energy is produced by any vibrating body. right? So that's what, and it is sensed by our ears. Okay, so then next, what is magnetic energy?
Energy consists by magnets to attract magnets.
Right. So if you must have seen toys with magnets, right? So magnet attracts iron pieces or metal pieces, right? It is different than electrical energy, right? How do you see motion in case of electrical energy? Like the electron moves when it falls between two differently charged electrodes. But that's not magnet. Magnet is naturally, like in old days, you remember what's the natural magnet? Lodestone. Yes. So when these guys, used to go, the shepherd, etc. So the nails in their shoes used to come off because it used to get stuck. Their shoes used to get stuck, okay, in those areas. That's how we discovered lodestone. So it's different. It's not due to charged body. It's a different property. Okay, and you will learn that magnet anywhere where electric current is flowing in the nearby region, there are magnetic fields. Okay, so we'll learn about it later on. Then what is mechanical energy? Everybody knows.
Motion. And this for the square body in motion or.
Motion or at rest or change configuration. So mechanical तो पता है. Now all these forms of energy so some of them can be converted from one form to other, right? So there is a big list given over here, right? First we'll discuss this diagram. So it has 1, 2, 3, 4, 5, 6, 12 conversions of energy. And the examples given in the book is 17 or 18. Huh? So you will understand, once we discuss this 12, right? So questions are like, you'll be given some process and you'll be asked to identify which type of energy is getting converted into what. Okay, like that. So, question, give an example of conversion of mechanical energy into electrical energy, right? So, it is with the help of electric generator. Okay, so electric generator is something which will produce electricity. So, like I said, inside generator you have a coil. So, once that coil is rotated, then electricity is produced into it. You will learn all this thing in detail in forthcoming chapters. Okay, so this electric generator is also called as dynamo. Have you come across dynamo? Have you seen some cyclists when they run the cycle, they produce electricity? Have you come across it? No? Like in the cycle handle. So this is right. So have you seen some small device? When this tire rotates, okay, there is a small device which rubs on the tire. This is called dynamo. A small generator is called dynamo. And then the electricity produced is reaching the bulb which is fitted here. So it will show light. Okay. So the mechanical energy, when the person pedals it, okay, just understand. Okay, when he pedals it, only then it will glow. When he pedals it fast, the light intensity will increase. So what is happening is his mechanical energy is transferred into this rotatory coil of the dynamo, and then this is producing electricity. Okay? So go and check on Google today what is dynamo, right? So what is dynamo at a smaller scale? Generator is at a commercial scale. So the electricity which is coming to our houses, okay, it is produced in electricity plants like hydel plant, nuclear plant, and what they have big generators. So when we rotate the coil inside the generator, electricity is produced. Okay. So which energy is converted here? In the first case, mechanical energy to electrical energy. Because mechanical energy is rotation of the gear, and that is giving us output as electrical energy. Now, second example, electrical energy conversion into mechanical energy. Can you give me an example in this room? In this room, do we have electrical energy getting converted into mechanical energy? In this room, fan, right? So when we switch on the fan, current goes in, and therefore the fan rotates. Motion is mechanical energy, right? So, which device is required to convert electrical to mechanical? We call it motor. Mechanical to electrical, we call it generator. Okay, so keep these two things in mind. Generator is a device to convert mechanical to electrical. Motor is a device to convert electrical to mechanical. From your house, do you have any device which uses motor apart from fan? Anything? No, it should be no expectation. Grinder will, right? Mixer grinder. Switch it on, now start steam, juicer, right? So all of those devices have motors. Okay. Next is electrical energy to heat energy. We use electric iron, right? Press current in it, so electrical energy is converted into heat. Heat energy to electrical energy, we have thermocouple. What is thermocouple? You can see the diagram. There are two beakers. Okay. So in one of them you have hot liquid and the other one you have cold, right? And this wire you see are basically two junctions. Okay. So, are you understanding what? Have you written it down? No need actually. You just understand it. And you can see the video lecture just in case. So how do we convert heat into electrical? So heat to electrical. Electrical to heat is iron. Okay. Now we are understanding the reverse. Heat to electrical. What do we need? Thermocouple. Thermocouple. The couple, as you know, couple means two, right? So basically, what do we have two? We have two different junctions, right? So how are two different junctions? We have two different metals. Okay, let us say this is copper and this is silver, or brass, copper and brass. Let us say this is copper and this is brass, green one. So we have junction 1, junction 2. Okay, so whenever they are maintained at different temperatures, right? Right, let us say this is a temperature T1, and let us say it is hot, and this one is cold. The moment we maintain two different temperatures, there will be potential difference which will generate between these two. Okay, so now if we connect any bulb, it will glow. So the moment the temperature difference is maintained, it will start glowing. So this is called thermocouple. Electricity produced due to difference in temperature, thermocouple, hot cold couple. Okay, electricity produced due to difference in temperature, right? So electricity can be produced in so many ways, right? This is another way. Okay, समझ आया? Yes or no? So like scientists keep doing various experiments, they keep finding different ways, right? So this is one way. So you have to keep in mind कि यहाँ पे what conversion is taking place? There is a difference in heat. That difference in heat is appearing as electrical energy. Okay, heat to electric. Got it? So that was the second example complete, right? Now we have electrical to sound. Where do we convert electrical to sound? Loudspeaker, right? Then sound to electrical microphone. Okay, easy. Then electrical energy to chemical energy.
Cell, dry cell.
Dry cell. Okay. When you are using it or when you are charging?
Charge is drawn from.
Huh?
And charge is drawn from.
No, then it is not. So when charge is drawn, it is chemical to electrical. Because when charge is drawn, you are using the cell. So that means
when electricity is supplied to.
when the electricity is supplied to it for charging process, then it is electrical to chemical. Okay. So, okay, you would like to draw it, or rather take a mobile shot or because I want to explain this part and you should not miss it. So, has everybody understood how electrical energy is converted into chemical energy during the charging process, right? And how chemical energy is converted into electrical energy?
That charge, electricity is drawn from the cell.
Yes. Okay. So you have to pay attention to understand that because otherwise you will not be able to answer the question. थोड़ा सा दो बार पढ़ना question. Okay, you understand. Okay, what is the example of chemical energy converted into light energy? Chemical to light. Huh? How? How is sun chemical to light? Nuclear I can understand because inside sun fusion reaction takes place. Like many hydrogen nucleus fuse into become helium nucleus. So sun is nuclear to light. So chemical to light is okay. You said light to chemical. What did I ask? Chemical to light. Anything you burn, any like candle or coal, right? When you burn coal, what do you get? You get heat and light, right? When you burn any substance. Then light to chemical photosynthesis. That's when light absorbed by sun is used to cook food for themselves, which is photosynthesis, right? Okay. Light to sun. Electrical energy to light energy. Tube light, bulb, right? Light energy to electrical energy. Solar cell. Solar cell. Okay. So I think we have covered up to 12. Up to 12. Right? Now remaining. Next is heat to mechanical energy. We have covered with the help of diagram up to 12. Now 13 job. So heat to mechanical energy is steam engine. So are we seeing any steam engine these days? No. But in movies we can witness that it used to be possible, right? So steam engine. Chemical energy to heat energy. Burning of coal, right? So chemical, yeah. So chemical to heat, burning of coal, wood, biogas, all of that, right? One more example, respiration. The process of respiration, when we are breathing, what are we doing? So when we inhale oxygen, through our lungs, it gets mixed into blood, and that gives us heat. Okay, so chemical reaction, right? Oxidation reaction, and then it produces heat. So that is chemical to heat energy. Right? Chemical to mechanical energy, again similar. Like steam engine also could be an example, or any automobile. Petrol, diesel you burn. So any burning has chemical energy. Burning से क्या होता है? There is a combustion engine. Okay, so then the engine starts, the piston starts moving, and it is given to the wheels. So the movement is converted into rotational motion, right? So that is an example of chemical to mechanical energy. Then you have electrical energy to magnetic energy. So any electromagnet, right? Any electromagnet. So making of an electromagnet is electrical to magnetic. Mechanical to heat energy. Mechanical to, not nuclear reaction, mechanical energy to heat energy. Nuclear energy to electrical energy. So I don't have it in my book. That's a new idea. Okay. So nuclear to electrical, I explained to you how it is, right? So what kind of reaction do we use in nuclear reactors? Fission or fusion?
Both.
No, fission only. Fusion takes place only at sun. Because to cause fusion, we require very high temperature. And at that high temperature, no container would survive, it will melt. Okay, so we can't make devices so which can allow us fusion reaction as of now. So research is still going on, right? So nuclear to electrical is through fission. So VARC is nuclear reactor using fission method, right? Okay. Then mechanical to heat energy.
Friction.
Friction, yes, very good. So all the machines which has moving parts, you would see that it gets hot. Whenever the engine runs for some time, even if you touch the fan from below, it is running, it becomes hot. So the motion causes heat energy because of friction. Also the falling water, okay, you'll find when it hits the ground, it becomes hot. So it hits the ground, so it becomes hot, right? It produces sound also. Or even in bathroom, when you use the tap water, when it runs from terrace to it comes out of the tap, even though you have not switched on the geyser, still its temperature is little warm. Okay, so it's due to friction of water with the pipes. Okay, so have we completed all the forms of energy? One very important last thing is, whenever one form of energy is converted into any other form, it is not 100% converted. Some energy is wasted, right? Like 20% of it is wasted. In what form it is wasted? It is wasted in heat energy. Like if I spend 100 rupees, I am getting only 80 or 70 rupees worth of it. 30 rupees is gone, it is wasted. So the wasted energy is called degraded energy. Right? Because whenever we are using any device, okay, so every device would have a moving part. So some of the energy would be wasted as heat energy, and it is submitted to the environment. So I'm not able to make use of it. Got it? So that unuseful or wasted energy is called degraded energy. Right? It's given in your book. Yeah, it's degraded. So with this, the second part of work power energy we have finished. In the next class, we will be able to finish the entire chapter and we will start doing numerics. This was lecture number 3 for this topic, or 4? 3. So keep a record of that. So is it time? Or we still have 5 minutes?
5 minutes.
We still have 5 minutes. So do you have any questions on what we discussed today? So there is a friction, no? When it hits the ground, there is a friction between the rock and the falling water. Right? See, you clap. Do you feel the hands getting warmer? Clap. Clap 4 times. Are you feeling some warmth? So whenever two bodies collide, it produces a lot of heat. Right? Friction of stone will produce a lot of heat. Have you seen that? Huh? It produces fire, yes, exactly. And that fire has heat in it. So, what is not clear? In the falling water, when water falls from a height, the potential energy stored in the water so when the water is at height, it will have potential energy, right? So which energy is getting converted? The potential energy stored changes into kinetic energy of water on striking the ground. So that is understood, potential to kinetic, but what about heat? When it strikes, okay, so part of the kinetic energy of water changes into heat energy due to which temperature of the water rises. Part of it changes into kinetic. What about the rest of it? It is still kinetic because it is floating, right? Right? Okay. So it will be warm water. What is happening to you? Chair. It's very funny, yeah. Okay. So is it clear now? So this you remember, there could be a numerical, right? And that's where you have to use the formula for the, potential energy, and that you have to change into kinetic energy. So we'll see it whenever that numerical comes. Okay. We still have 2 minutes. Anything you would like to tell me or ask me? Okay, are you okay with the way lectures are going, or you want me to change to my style? Like, am I teaching slow, fast? Is it okay? Everything fine? So just feel free to ask anything if you have any questions. When is your test? Physics का टेस्ट हुआ क्या? कैसा हुआ? Have you got the results? How did you find the paper? Okay. Easy था. Good. I mean, was there any question when you felt that ये पढ़ा नहीं है या नहीं कर सकते? No? नहीं ना? चलो ठीक है. Marks अच्छे मिल जाएंगे. Okay. Good. All right then. I'll see you in the next class.
Bye, sir.
क्या बोल रहा था कि कैंसिल होगा देख 2 मिनट पे ही खड़ा है कब से
दवा एक बार कैंसिल
देखो 2 to 1 जाएगा मतलब वो खराब है फिर खड़े मुझे लगता है ये क्या है ऐसी रिकॉर्ड मेरे को पिक्चर भेज देना
अच्छा
साथ साथ कर रहा है हाँ